Hello everybody, welcome to the last standard track of this EuroPython. Welcome Alessandro and his talk on JSON web services in Python. Thank you.
Okay. First of all, who am I? I'm currently working as a CTO at Docstrings, which is a small development company in northern Italy, and we work mostly on Python for everything that is server-side, and we have to do some iOS and Android development for applications that contact Python web services to retrieve data and perform whatever they need to do. And this is the reason why I'm going to talk to you about web services with Python. Then I'm a member of the TurboGears 2 development team, and this is the major reason why you're going to see a lot of TurboGears code in this presentation. If you are a Pyramid user, I'm sorry for you. You can tell me why you prefer other solutions after whenever you want. I'm a MongoDB user, fan, and Ming object document mapper contributor, and we are going to see some of the reasons why Ming and MongoDB are really good choices for web services, and especially when working with JSON. And I'm a skeptic developer, always looking for a better solution, so any suggestion is greatly appreciated. First, what we are going to see. My talk will be on rapid prototyping of web services, so making possible to have a working solution in the minimum time possible, so with the minimum effort, and making something which is possible to expand later when you need to perform a successive release or when you have the budget and time to make it happen. We are going to see a bunch of tools to document JSON services, because whenever you are going to make a service, someone else will need to call it. So documenting it is one of the core parts of developing a web service. And we are going to use Ming to see how to use Ming, MongoDB, and especially the Mongo memory feature of Ming to make a full test server and writing text features without having to actually run a MongoDB server on your machine. And we are going to see a bunch of tools to deploy fast what you did, because we are looking at rapid prototyping, so the deployment should be as fast as possible too. Why TurboGears? Well, TurboGears has one great feature, which is that you can start small with the so-called minimal mode. You don't need to bring in any dependency. It works much like a micro framework. I don't know if the term is correct, because now it's really hard to decide what is a micro framework, as they actually have most of the features that a full stack framework has. And whenever you need it, you can easily scale to a full stack framework, full featured environment with packages, with authentication, and whatever you might need to, without having to actually set up anything apart setting an option to true. And then TurboGears does that for you. TurboGears uses a special dispatch system which doesn't rely on regular expression. It's much like the traversal dispatch system of Zo pyramid and so on, but uses objects hierarchies instead of dictionaries. So you just declare your objects, provide some methods, and those methods are automatically exposed as services to your front-end user. And it also has a specialization of the object dispatch system, which is the so-called REST controller, where you just declare a REST controller and put inside each HTTP verb as a method of the REST controller, and it gets automatically dispatched to the correct verb. And TurboGears has a way of implementing validation which copes great with APIs, because it uses decoration on the arguments of the function, so you can actually set up validation for each argument your function is going to receive, and so it's applied to any argument which is passed to the API service through being it a post multi-part encoded body, being it well encoded in your GET request, being it whatever you are receiving from your client. So this is the minimal mode I was talking you about. It's actually really simple to start this way. You just import whatever you need from TurboGears. You set up your root controller, which is going to be the root of the dispatch, the kernel, the core of your dispatch system. And whatever you expose with the expose decorator inside your root controller is an API available at the URL with the same name of the method you just wrote. If you set expose JSON, TurboGears will automatically render the output of the of the method as a JSON, in this case dictionary, or better say object, as we are talking as JSON. Then whatever you pass as an argument to your method is actually passed as an argument to the underlying function. So whatever you pass, being it through the GET request is URL encoded, or being it even as a JSON encoded body, every variable of the JSON object is passed as the argument if you are using some kind of decorators you can enable on TurboGears. And then to start your application, you just need to create an application config, tell him which is the root controller you want to use, tell him that you are in minimal mode, and make it happen. You just create the whiskey application from the configuration, and TurboGears will set up every middleware or feature or whatever you need for you, and you can just serve it. Of course, you don't want to serve it on whiskey reference in real world, it's just to show you how you can achieve that. And to start it, you just save your file, run Python, point your browser there, and you get your JSON back. So we created a a JSON service in like 30 seconds without any effort required. And this is probably the most simple solution you can achieve on a server. It requires minimal configuration, it requires no routing specification because you're just relying on object dispatch. It requires no JSON manual encoding because the framework is going to do that for you, and so on. You can achieve similar speed using a lot of other different solutions, like every other framework has some kind of rapid prototyping tool for your API. So this is just the way TurboGears does that, but you are not forced to using that. And then where you are going to store your data. When you need to create an API service, or you are a really lucky guy and you don't need to store anything, or you are probably going to save, retrieve, and update, and so on data. And you can do that using MongoDB. And MongoDB is a great match for API services because if you design your collection properly, you can actually make most of your APIs are probably going just to be a find, modify, atomic operation. So with a single call to the database, you can actually perform complex operations like updating multiple objects, updating values with the value of something else, pushing to a set, making sure it's actually doesn't have duplicated elements, and so on. MongoDB provides a lot of operators that make possible to perform on database side complex operations. And this is one of the reasons why it's really good, because your API server became just a proxy from the HTTP level to MongoDB, reads your data back and goes on, which copies great with asynchronous servers like Gevent and so on. And this is one of the reasons why PyMongo, which is actually the underlying library that Ming and other ODM use, it works great with Gevent. You just enable patch everything and you don't have any issue. Your connections to the database became asynchronous and you get data whenever your GNR dispatcher permits that too, and so on. And you can use sub-documents in MongoDB. So if you have like an article with information on the author and comments and tags and so on, you can store everything inside a single document. And whenever you need to update the document or so on, you just need to update in a single place. And again, you can use a single call to update everything because everything is inside a single place. Then if you need to perform like logical connection or more complex analysis on your data, you can actually use a reference, which are like a simple form of joins. I don't know how to explain them. You just a pointer to a collection entry, so you can perform analysis you don't know before how your data needs to be structured to perform that kind of computation on your data. So you just structure your database the way you are going to use it most often, and then for everything else you use relationships or duplicate data or whatever you prefer to do. And it provides GridFS, which is a great tool that permits to store files inside MongoDB itself and use the sharding replication and so on of MongoDB itself to store the data. So you're actually going to have something which is replicated file system, distributed file system, are very fast in reading because you're going to read from every shard available. So also MongoDB keeps a lot of data in memory, as much as possible for the server you are going to put MongoDB on. Its residence set will be as much as possible. You're going to allocate all the virtual memory available. It's going to keep in memory as much as your users are going to use. So your files will probably be served directly from memory and not from disk, because they are probably going to be in your residence set of the MongoDB server. And it scales. It scales really easy, and it's so much important today. The scale word is the most common one on web blogs. And this is actually how MongoDB scales. You need to scale. You just start another MongoDB server, and it attaches to your Mongo distributor, Mongo's proxy, and so on. And you have actually automatic sharding and so on, so you don't have to perform anything. You start another server, the server themselves shard the data to all the servers. You just need to declare a sharding key, which has to make sense, because if you declare a sharding key which doesn't have enough, which is too linear, MongoDB is going to store all the data on the same shard, so it becomes useless, because MongoDB reserves chunks of data for a shard. So like if you use an auto-increment key, it's going just to be stored a bunch of subsequential data on the same shard. If you use a totally random key, you are going on the opposite, have everything distributed on shard, but you are not going to be able to know on which shard you need to perform the query. So queries will be really slow because they need to be performed on each shard. So the only effort you need to put is in studying a correct sharding key for your MongoDB cluster, and then MongoDB does everything for you. And also it's really, really easy to enable it on TurboGears. Whenever you start a TurboGears project, you use the gearbox quick start command, and it creates a project skeleton for you. It creates like controllers, models, sample pages, which you're probably just going to trash away for a web server, but they are there. It places static file serving in place for you. It sets up authentication if you want, but it sets up the database for you. And as it sets up the database for you, it permits you to choose which database you want to use. If you don't say anything, it's going to be SQL Alchemy. If you say -- Ming, it's going to be Ming, so MongoDB. And then you just tell the project name, and then it's created for you automatically by the Gearbox toolkit. If you want to have some information on how Ming and MongoDB work with TurboGears, you can give a look at the TurboGears documentation, which has actually an entire section on MongoDB. And if you are coming from SQL Alchemy, like you probably are if you are a TurboGears user, and nowadays it's probably the most common object relational method in Python world, or I should say database toolkit actually has a lot of things more than URM. And you can give a look at the merciless.sourceforge.net documentation, because Ming is actually the evil emperor of Mongo, so it's Ming the Merciless. And Ming has been designed and developed as SourceForge for their own use, because they work on TurboGears and MongoDB for all the website. And they develop a Ming which works much like SQL Alchemy. So if you are used to SQL Alchemy, the query syntax is really similar. You just perform the query operation the same way, apart from the fact that MongoDB has a totally different query language, of course, so you're not going to write filter or limit or things like that. You're just going to write the syntax for MongoDB, the operators of MongoDB. And it works with the unit work, so the pattern is much similar to SQL Alchemy. You just say every operation you want to be performed, every update or insertion you want to be performed in your unit of work, and then when the unit of work gets flashed, the operation happens. If your program crashes or doesn't flash the unit of work, it removes it, it trashes it away, no write operation happens. So it's useful when you have like a code that might not work and you want to avoid writing data on the actual database. Just pay attention that SQL Alchemy, as it works with SQL databases, is often used in transactional model, while MongoDB has no transactions. So if you have wrote half of the data and it crashes while flashing the unit of work, you just wrote half of the data. So you probably need to keep track of what you're writing, perform two phase commits, and so on. And you can, if you want, just totally skip the unit of work and go barebone at the MongoDB level, which is really cool because in that case you can use atomic operation. MongoDB provides a bunch of atomic operations which are performed like in a transaction. You don't have a transaction, but you have some atomic operators. So you can perform them without having concurrency problems. And atomic operators are actually really powerful because they can do a lot of complex things. And as I told you, it's a perfect solution working on really big size, so it's stable, used, development. MongoDB is a really old system. It has these issues. You need to study it before starting to use it. I saw a lot of blog posts complaining on MongoDB is broken or I lost all my data or things like that. It's true. If you don't know how to properly configure MongoDB, you are going to lose your data. So pay attention, read the documentation, understand what the database does by default and what it doesn't. That's really the all important thing with MongoDB. And then after we wrote with our API and we are able to store and retrieve data, we probably want to write our test unit because everyone here writes test suites, right? So we can use the so-called Mongo in-memory representation, which is much like the SQLite in-memory representation, if you ever used it. Instead of having a real database working on your machine, you just have the database driver implementing all the database interface and saving your data in case of Mongo in-memory dictionaries, collections of dictionaries. So you can perform the same operations you can perform on MongoDB. You just use Ming, but you tell to Ming to connect to MIM, which stands for Mongo in memory, and it doesn't connect to any database. It just keeps the data in memory, and you can perform atomic operation, updates, pushes, or inserting data, deleting data, looking for data. And it even has support for JavaScript. You know probably that MongoDB can perform JavaScript on server side. You can use the where operator, or you can perform map reduces, writing JavaScript code that gets executed on the server. And if you're using MIM and you have installed SpiderMonkey on your system, you can use the JavaScript code execution even with Mongo in memory. And when you start the TurboGears project, by default, you get a fully working test suite with the feature to set up your models, your database connection on MIM, and so on. So you get it for free if you are a TurboGears user. So you just want to use it because it's so comfortable, so convenient that there is no reason to actually start a MongoDB server and use that. While you want to have a staging environment where you have a real MongoDB server, you want to have a continuous integration system where you have your real MongoDB server, but on your system to just check your code before committing, MIM is perfect. Now, we have everything in place and something probably breaks, like it always happens. Whenever you start your server, it just crashes the first time you start. So you need to debug. How you can debug? Well, the TurboGears provides the so-called DebugBar. It's really common in every framework. You have one in Django, you have one in Pyramid, and as far as I know, you have one also in Flask. So you can start the DebugBar and have every query that gets executed logged on your shell and logged on the DebugBar. You have the timings of your queries. You have, in case you have JavaScript inside your queries, like you have a where lookup or you have a map reduce execution, the debugger is going to prettify and highlight your JavaScript because you are probably going just to put it inside a Python string, so you don't understand anything as far as the JavaScript gets bigger than 2 lines of code, because we are all lazy developers and we mix JavaScript and Python always. So the debugger is really useful because it performs all of these features. It also performs like profiling of your Python code, timings, and whatever you might need to know while developing your application. But it's really good also for having an actual knowledge on how fast your server is, how fast your API is, because it keeps a log of all the performance of each request you got, so you know how much time it has been spent in performing a specific request, and you know each query that got executed for each request, so you know where you are going slow and why you are going slow. You probably just mixed an index, you probably just did something without a limit somewhere, and you are loading the whole database in memory, what the DebugBar is going to tell you. So you can just go back to your MongoDB, create your index, and then go back and see your web service going fast. And this is the actual DebugBar in action. This is a screenshot of a really old version. Actually, it changed somehow the interface, but the concept is still the same. We have nearly the same data. And you can see that for each operator that got executed my page, in this case a JSON page. So I don't know if it's correct to call it a page, but as the DebugBar is HTML, you can see it inside the JSON documentation, and it gets cast to HTML, the whole thing. And you have the time spent by your command. You have the command you executed. In this case was a find for a group. Group was just a model of the user's groups and so on. And you have each parameter you sent to MongoDB, which in this case was nothing, which means get all the groups. And you have like, here you have a lookup query which performs a JavaScript statement to actually do like nothing. It's much like a sleep. And you can see that it gets highlighted for you and so on. So if you want to rapid prototype something, we have seen that TurboGears and MongoDB are really good tools for doing that. But you probably want to try also the tgext.crud extension, which is a TurboGears extension that automatically generates for you your REST APIs. It's really good when you need to start with something. You are probably not going to end up using it for the whole program, for the whole software, but it's really good when prototyping APIs. Most people in the TurboGears community actually use it only to prototype HTML, create, read, update, and delete controllers, but it actually creates also the APIs for the same operation, so it's really good. It has a really good REST implementation. It performs like validation on the arguments. It returns the correct error code as far as our common conception of correct error codes, as REST doesn't enforce any. It will tell you what went wrong. If an argument is missing and was enforced, it is going to tell you a bad request, this argument was required, and so on. And it's built-in validation, and as I was telling you, which is automatically detected by your model description. You can customize it if you want, but by default, it's detected automatically. And as it is just a subclass of the REST controller, you can just customize it. Want to replace the behavior of your put request, just override the put method in the tgext.crud controller, and you can write it on yourself. Want to inherit the decoration, so the validation and everything else, you just expose it as an inherited method, which is something that TurboGears permit. You can get all the decoration of the parent class method without getting the actual implementation, only the decorations. So it works on both SQL Alchemy and MongoDB. So you can use it actually wherever your database is. And this is pretty cool because sometimes I have seen, like in my company a few times, we started with a SQL database and switched it to a MongoDB just because we saw that the major use case for the application was just like reading two tables constantly. And in the case you just probably want to make one a subtable of the other. And as the MongoDB permits to have subdocuments, we often switch back to MongoDB. And in that case you can use the tgext.crud to manage your API because you just switch the backend and everything was like before without switching much code apart the model definitions because you are switching from an ORM to the other one. But as Ming and SQL Alchemy have similar syntax, it just ends up being something like a search and replace in your model file. It can perform substring filtering. A lot of other solutions for REST APIs just perform exact matches. So whenever you are filtering your like get all requests or so on, you probably want to look for something that is named somehow like that. and most API auto-generators don't support that, while the tgext.crud one permits that, and also has a lot of configurable features. So you are probably not going to need to overwrite anything unless you have some kind of specific requirement, because you can use like multi-part URL encoded parameters. You can use JSON body with a JSON object with all your parameters inside. You can use the conditional put method if your model has an updated at field or whatever you called it. So you can have put that don't update the object if it has been modified in the meantime since you got it and you are updating it. It can automatically perform serialization of relationships, even many-to-many relationships, and it can update many-to-many relationships and so on, which doesn't make a lot of sense in MongoDB, but it's really useful if you're using SQL Alchemy. And by default, has a really configurable pagination system, but this is something that most API servers have it. So you have your API server in place, and now you need to use it in your client application or front-end website or whatever else. And if you are like me, you probably just forgot everything you wrote the moment you switch the project. It always happened to me, I don't know why. I don't remember the API definition I myself declared. And then if you know other people, the other team members don't know it because you wrote them and they aren't going to use. So be your team hero, write the documentation. And this is Document, which is the hero of your team and is the one which is always in charge of writing documentation, because there is only one single guy that at one time looks at the code and says, we need documentation, and goes and writes it. And he has Sphinx superpowers. And some of his superpowers are actually made possible by sphinxcontrib.jsoncall, which is a Sphinx extension, which is pretty common in the TurboGears world. It's not, I've seen not much it outside, but it extends the sphinxcontrib HTTP domain extension for Sphinx and makes possible to document JSON-based URLs. What it does is just using the same syntax of HTTP domain, but it happens a playground for your API. So it declares a form inside your documentation page where you can write the actual data you want to send API. You have a submit button, it gets sent to the API, and you see in real time the response of API. So you can play with the API, you can make example calls already available inside the documentation and so on. And of course it prettifies your response, so you don't end up looking inside the browser as the response and you don't understand nothing because you get just a huge bunch of JSON which is not indented and so on. Unless you're using an indentation plugin, of course. And this is what you get. This is a real-world example from one of our references. And it's a really simple API, gets only one parameter, gets the ID of the object. It's not REST. The guy that started it didn't like probably the idea of having something REST. And it returns the information of the present you were looking for. Only if it is a public present. It doesn't return information on private present. And you see under that you have the sample call, automatically indented by you. So you just call the API and copy and paste inside the docstring of the API the sample result, and it gets automatically indented and highlighted for you by the Sphinx extension. And you have a field where you can write any object ID you want and submit it and see the data of the actual object. So it provides a playground for the users that are reading the reference to start trying the API and see what happens and which data you get. And if you are using TurboGears, you also have the tgjsonautodoc extension, which is part of the JSON call extension, which automatically generates the documentation. It looks in your code, in your application, for every single method that is exposed at JSON. You can, of course, skip this method, but it looks in your code and it reads the docstrings and automatically creates the reference for your APIs. How is that done? Well, it looks at the method definition to see which arguments are required. It looks at the validator definition to see which validators are in place and tell to the user, like, this field is required to be an integer. If you write here your surname, you are not going to get anything. And it automatically generates a form with some sample data. Like if you declare this as an integer, you get a default value for an integer. It just uses the validation definition to see which is the right type to use. And then, this is a real-world example. This is how tgjsonautodoc looks like. You have your method, you have your exposed JSON to tell to TurboGears to encode it as JSON, and you have your validators in place. In this case, we have an optional player. You can put it or not. We have a count, which tells the API how many results you want to know. And you have an error handler in place that if some requirements are failed, it just returns you are forbidden to access this API. And you see under the Docstring, which is actually automatically parsed by tgjsonautodoc. And the Docstring has the classical information of what the API is going to do. And then you have the special syntax. The query parameters are actually from HTTP domain, so you can use it for any kind of URL, not only for JSON API. And you have the JSON call information, which tells how the playground form is to be generated. So you have where you need to submit your data, and you have like the default arguments if you want to put them in place yourself instead of auto-generating them. And you have a sample response you can put inside the documentation itself and get parsed and used as the default response. And to use it is really simple. Well, the first thing you probably want to do is put your documentation in a place which is reachable from your application yourself if you are a lazy guy. Otherwise, you need to place the allow origin headers in place. Otherwise, as soon as you try to use your API, you just get, your browser won't perform the request, of course, because your documentation is probably hosted in a different space. But if you just put the documentation inside the public directory of the application itself, it gets served by the same application, so you can use it and play with it. And to use the tgjsonautodoc, you just go inside your Sphinx configuration file, you enable all the extensions you need, like the HTTP domain, the JSON call, and the tgjsonautodoc, and then you link to the configuration file, the paste deploy compatible configuration file of your application. The tgjsonautodoc extension is going to load that configuration file, see which is the application model package in place, load it, and parse all the controller exposed by that application. And then you just need to put somewhere inside your documentation, hey, this is the reference, and say, like, put the reference here, and if you want to add it, you can say, like, skip these URLs because I don't want to expose my admin APIs inside the reference, and so on. And then the result you get is exactly the one we saw before, and your team members are now happy. As soon as they read your documentation, they are going to congratulate with you because you made their life easier in just like 5 lines of code. Now you have a fully working and documented API, and you probably want to deploy it somewhere unless you are a really happy guy with having your computer serving everything on the internet and so on. So when you want to deploy your API, you don't want to use the built-in server. It's something I saw people do a few times. It's something that doesn't work. It's not concurrent. It doesn't scale. It has a lot of issues and so on. You want to use a more structured and well-performed solution. And my favorite solution currently is Circus and Josette. There has been a previous talk by Tarexiad in this conference on Circus and Josette. It was a really cool talk. If you have not seen it, go on YouTube, look at the registration, and watch it because it's really great talk. And Circus and Josette are a super easy solution and flexible. They don't only manage your application, but they manage your whole ecosystem required by your application. And inside the TurboGears documentation, you have a web page inside the cookbook how to deploy TurboGears on Circus. So it's actually a first citizen for the TurboGears. It's one of the 2 suggested deploy methods. And you have inside the Gearbox toolkit some commands to automate the deploy configuration process. So what you need to do is just create a Circus configuration file. In this case, it's the minimal case. It's just a Circus session with telling an include statement to include the configuration for every application I have on that server. It's the minimal Circus configuration we require, no more to start using Circus. Well, you probably want to add a lot more options, but it's the minimal requirement. Then you move inside your application. You enable your virtual environment, the one you need to serve, you want to use with your application if you are using virtual environment. You want to install the Gearbox tools extension, so you have the commands to automatically generate the configuration. And then you just run Gearbox deploy Circus, in this case with the Gevent backend. You can choose a lot of different backends. Josette is the Whiskey server used by Circus. It's not the only one you can use, but it's like the default one. And Josette is actually not a real Whiskey server, it's more like a proxy server. I don't know if it's correct to call it that way, but it's much like what it does, because it binds to an existing socket opened by Circus itself instead of opening a new socket itself. It reads from there and then forwards it to a real backend. So you can use Josette with Gevent, Waitress, Mainland, or whatever you want to use. It just performs like a common setup interface for every different backend. So you started on Gevent and you want to switch to Mainland, or you started on Waitress and you want to switch on Gevent, you just change a single configuration line saying use Gevent as the backend, and now your application is on Gevent. And Josette exposes the same configuration interface for both Gevent, Waitress, or whatever you want to use. So you don't have to set up your configuration deploy again from scratch. And then I save the output of the command inside my configuration file, which is of course inside the configs directory, so gets included by Circus itself. And then I start Circus. I see in my logs, my project started. So it worked like expected and required like single line of code, and I don't even need to know what has been generated. What is going to happen is actually that the deploy Circus command reads your application configuration file. When you're using paste deploy as the configuration system, you have an ini file or something like that in place. And the Circus reads that, decides all the options that need to be changed, like switches off debug mode, switches off automatic template reloading if it is in place, everything which is common in TurboGears when you switch from development to production environment. And it writes a Circus configuration for your application. And this is how a Circus configuration actually looks like. So it's pretty long but not really complex, and it gets written for you by the Gearbox command. The first line tells for my project which environment to set up. And actually in newer version of Circus you have a simpler syntax. You just can declare the environment for the process watchers and gets used. But this is what you did on like maybe 2 or 1 versions ago on Circus. And you set up the path where you will find your scripts, and you set up your virtual environment path so it gets used by the virtual environment. And you just set up your working directory for the watcher. How Circus works? Well, it starts a bunch of programs, so you can compare it like to daemon tools or other solutions, supervise the other solutions like that. So you just tell that your application is a command, and specifically a Josette command. You tell the backend, you tell Josette which file descriptor to use, which is the same that has been opened by Circus, and you tell to Josette which paste configuration file to load. And in this case, the production file that gets automatically generated by Gearbox itself. And then you can set up like the number of processes and so on for your application, and you can redirect the output stream if you want to save whatever your application writes or logs somewhere. And like you declare any socket that needs to be opened by Circus. If you declare them that way instead of letting your command open the socket, it's far more faster because you actually reuse the same socket instead of opening and closing a new one. And Circus can actually orchestrate your whole stack. So this is a really cool feature. Circus is actually a daemon, a process manager. I will call it something like that. You just start Circus, and then Circus looks at your configuration files and starts all the processes you need to have to make your application work. So like your application requires Redis, you add the information of how to start Redis to your Circus configuration, and it gets started with your application. And you can even choose the sequence of operation, and you even have a bunch of plugins to monitor the state of your application. By default, Circus has a web interface that tells you like the memory consumption, CPU cycles, and things like that. And you have also a bunch of plugins for specific services, like you have a Redis plugins that instead of just watching if Redis is in execution, it also tries to connect it to see if it is actually working, there's not froze or things like that. And so you can perform actually a lot of complex operations which are usually performed by third-party tools or things like that in a single tool. As like plugins for Celery or whatever you might need to have. There is also a plugin to have a virtual host manager inside Circus. So you can just start Circus, and Circus starts a plugin that listens on port 80 and forwards requests to your declared applications inside Circus. So you can avoid having a front-end web server if you want, for example. That's probably not something you want to do on production, but it might be useful in your continuous integration system or continuous deployment system and so on. And if you want to have more information on Circus, you can actually give a look at the Circus documentation, which is pretty well written, has a lot of examples, and you will find everything you might need to know there. So, questions? This is practically everything I wanted to tell you.
Great, thank you. Very interesting. I've seen, I do a lot of high-frequency JSON stuff, and seen there's a bottleneck with encoding and decoding JSON using, for example, simple JSON is quite slow. Now there's other alternatives. What is TurboGears using by default?
Well, actually, TurboGears uses simple JSON by default. So if you have the C speedups in place, it's not so slow to be your actual application bottleneck, but it can be the issue. One of the things you might want to know is that there is some way for using MongoDB as a pass-through, because MongoDB actually uses JSON for internal representation and returns dictionaries and so on. So you can actually, when you are using JSON to send back your response, you're actually encoding in JSON 2 times, because you get the JSON in the middle and then you encode it again, which is something which is actually really complex. People don't do that because you are messing with the internal stuff on Mongo and so on. But you can retrieve the binary JSON itself and send it back and so on, which skips an encoding part. I don't know if you want to do that. I think that encoding JSON is not a real bottleneck of your application in real world. It's probably going to be your database, the first bottleneck, and things like that. But there are anyway some faster libraries. I never tried them actually. I usually rely on simple JSON with C speedups in place. It's pretty fast. But I saw that there are a bunch of Python libraries that wrap C encoders, and there are some of them which actually also work with streamed response. So when you need to parse JSON, you don't need to have the whole response. You can parse pieces of it and things like that. Just look on GitHub. I remember I've seen a bunch of them.
Anybody else? Okay, thank you very much.